The first step in the experiment is to align the laser to make sure that the laser is focused on the tin or YSZ sample. As you can see here, Greg is aligning the laser to be perfectly centered through the magnifying optics, and then he is making sure that the laser is also aligned through the quartz feed-through, which allows 90% transmission of the laser beam from the laser all the way to the sample. The next step involves placing the tin or YSZ sample onto the sample holder. Here you can see Greg is placing the sample onto the sample holder and placing it within the vacuum chamber, which he can then pump down if required. The last step is the ablation step. The laser is switched to Q switch mode from alignment mode, and the sample is exposed. Here Greg is checking to make sure that the sample has not been burned through, so that an accurate analysis of mass displacement can be measured. Each tin or YSZ sample was weighed before and after ablation to measure the amount of debris removed from the sample. Furthermore, silicon witness plates were placed near the blow-off location of the sample surface. These samples were analyzed using SEM analysis to determine how material was ablated from the surface, especially with emphasis on analyzing whether material was ablated in large clusters or more like an atomic spray.